Do you remember when you were in elementary school and your teacher had you read nonsense words? And the whole purpose of that was to make sure that you understood how to pronounce them. So it was a procedural check to make sure you knew what you were doing. That's exactly what this example is. It's looking at two functions that are pure nonsense. There's not a single number to be found. And so while you might feel that's a little bit uncomfortable, treat it like you would any other variable. Okay, so we're going to go walk through the process of finding f of g of x. And we know that that is going to be equal to f of g of x this way. So I have that outer shell, that's going to be this one. And then once I have that, this is going to get tucked into the guts. So let's go ahead and write my outside function. So I'm going to do z and then put parentheses where my x is and then put plus n. So that's my outside function. Now on the inside, I want to put tx plus u. So those are the guts that go inside. So now it's just a matter of going ahead and distributing that through. So I end up with z tx plus zu plus n. So that's the answer to my f of g of x. All right, the second question it asks is find g of f. So it wants to do the opposite. So it wants you to start with your g of x, and then you're going to have the other. So let's go ahead and write what that looks like. So g of f of x. So my outside guts is going to be t, and I'm going to put parentheses where that x would be, and then put plus u. Then on the inside, right, I'm going to use this function and stick that on the inside as my guts. So I have zx plus n on the inside. So if I solve that and I distribute that t, I end up with tzx plus tn plus u. Okay. And then the third question says, well, what is, let's see here. I believe it asks for the domain of f of g of x and also the domain of g of f of x. So the good news is that the domain of both of them are the same. So the domain of f of g is equal to g of f as far as the domain is concerned. And that's going to be all real numbers. So remember when we talked about as long as there's nothing in your denominator or something that could cause an illegal math maneuver, you are absolutely fine saying all real numbers for your domain. All right, so the last question, this is the one that gets a lot of people. It asked, how on earth can you guarantee that f of g, and this one was just the domain, is equal to g of f? All right, so there's two ways that we can look at this. The first way is if f of g and g of f are inverse functions, right? But unfortunately, we have not covered that until 5.2. Now in class, we've already covered it, but that wouldn't really be my first thing. The second thing that you might look at is what makes them equal. Okay, what makes them equal? So what I'm going to do is examine these two. So I'm going to pull this and bring it. Oop. Can I bring that down? I can't. All right, let me just rewrite it. So my f of g of x is equal to ztx plus zu plus n. And my g of f of x is equal to tzx plus tn plus u. All right, so let's examine what we have. This is ztx and this is tzx. These are the same variables, just in different orders. So those are the same, okay? Now, for the rest of it, in order for f of g of x to be equal to g of f of x, these values need to be the same, okay? So zu plus n must equal tn plus u. And the only way to guarantee that is if you subtract one chunk from the other, right? So let's say I want to go ahead and subtract this one. So I would end up with a 0 on this side because I'm getting rid of it. And then I would have tn plus u minus quantity zu plus n. And then, of course, when I have a subtraction of a quantity, I'm going to go ahead and distribute that negative. So tn plus u minus zu minus n. So that means if I can take one of those extra chunks and subtract the other chunk, it's going to equal 0. That would prove that these two things are equal. And that's the only way where you have both of those functions equal to one another.